features, what are the functions of your biological importance of your protein, so where we are using it, that and so. So in today's class, let me deal that one by one. Okay. So let us go with the first. So enzymes. So I put it some points and I'll explain it. So enzymes, so it's the first biological importance of your protein. So as I told in my last classes, enzyme is a protein. Okay, enzyme is a protein. We are saying that all enzymes are protein, but all proteins are not an enzymes, but all proteins are not an enzymes. Okay, this statement you should remember always. Okay, it's showing blur, right? Because of network. For me only, it's showing a network band wide, so it's low. So please adjust for a while, and I'll try if it is possible. Right. Okay. Fine. Does it bit okay? You just listen to my words and start writing it. Okay, all enzymes are said to be as protein, but all protein are not an enzyme. Okay, so now, what do you mean by enzymes? What do you mean by enzymes? Enzymes are the classification of biochemical reaction, or it's an, sorry, not classification, it's an catalytic compound. You should remember this word, catalytic compounds. So what do you mean by catalyst? What do you mean by catalysis? Catalyst. What do you mean by that? So, and a substance, so whatever the substance which have the capacity of hydrolyze, hydrolysis. So for example, as I showed you in my last class, a thread, that thread can be wind dip, so it is called a quaternary structure of protein. And from that protein, if you take a scissor and start cutting without any positions or randomly, you'll get a species of fragments of thread that is called as uh, what to say, your hydrolysis. So same like that, catalysis, what that will do, that scissor will acting on a catalyst. So the scissor, what you are saying, we call that as a catalyst. Okay, so what it will do, enzyme is a substance and it is a protein which having a definite shape and structure, which will do the function of your catalysis. What do you mean by catalysis? It start hydrolyzing the large molecule into smaller fragment. Okay, large molecule into smaller fragment. So what does it mean? Suppose I think you might have know what do you mean by starch, cellulose, and glycogen, because as we already read with in the carbohydrates topics. So this carbohydrates, the starch, cellulose, and glycogen is in carbohydrate. We can say that it's a polysaccharide. What do you mean polysaccharide? A long chain of your monosaccharide units are said to be as and polysaccharides. Yes, that is right. So that polysaccharide chain you have, that is heavy molecule. Suppose I can write like this. This is your polysaccharide chain. Just think it like this. So what it will do when you are taking food, when you are taking a food through mouth, you are saying that by chewing the molecule or substance can be reduced the size and that substance can be absorbed by our body, but that is not right. The thing here, whenever we are taking a food, suppose I'm taking one fist of your rice, so I'm eating it up. So in each of one rice pearl, you can see much more number of carbohydrates. Okay, you can see the much more number of carbohydrates. That carbohydrates, okay, that carbohydrates, what does it do? It will take up, okay, that carbohydrates will take up by an enzyme and it starts cleaving the biggest molecule as a large molecule into a small fragment. That is the work of your enzymes. So what does enzymes do? Enzyme take the large molecule and it will break into a small pieces. So by chewing, yes, you can give, you can reduce the size of it, but the invisible components are more in that food. So it needs to simplify the process, or the helpful component for simplification of that is your enzyme. Okay, are you clear? Are you clear? So suppose I'm giving one example. This is a carbohydrate compound. This is like a starch. Just think starch. So what will happen? This is starch. So it's a bulk molecule. So it can't be absorbed by your blood through an capillary. So what you want to do? You want to take that enzyme. Sorry, you want to break this heavy molecule into small fragment until and unless the capillary should absorb this. Is it right? The capillary should absorb this. So at that time, what will do? Your enzyme. Suppose I'm writing like this. Your enzyme. This is your enzyme. Okay. So these enzymes will move like this. Just think my hand is enzyme. So what it will do, it will move like this and it will search for a food and it starts binding one part of the side and it encloses closely. Okay, this is your substance, this is your enzyme. So it start moving towards your substance. When it closes the substance, it covers it and it's try to break. So now let us see how it will break and what it will do. Okay, so this is your enzyme. I'll just reduce this size like this so it fits to the part of substrate binding site. So this is your enzyme, and this U-shaped curve is called substrate binding site. So it's called SBS site, SBS site, substrate binding site. Okay. So in this part, your substrate will go and sit. What it will do? This enzyme, okay, will have the hydrolytic component here. It start breaking. It start breaking your component, and it will leave a small fragments that may be your disaccharides or your monosaccharides. Okay, are you getting my point? So what is the function of enzyme? Enzyme will take up the large molecule, heavy molecule, and it starts degrading it up. It will break down and that released part will be absorbed by your capillaries. So it converts the large molecule into small fragments. That is the role of your enzyme. So the original definition of your enzyme is a protein. Okay, write it fast. Enzyme is a protein which is present in your living organism, which is present and produced, which is present and produced in your living organism. It will cleave, it having the capacity of catalytic behavior or catalytic activity. What your enzyme will do? Enzyme is a living component, it's a bulk of protein, it will do an catalytic activity. Okay, fine. So, what do you mean by substrate over here? Does that substrate should be carbohydrates? That is my question. Now, yes, Kavya, I'll repeat. So, see, this is your enzyme. Okay, this is your enzyme. So, please listen. These are all topic is very important for your exam point of view. So, you should be very careful of listening and you should understand. If you didn't understand, please stop me over there and I'll continue. No problem. I'll repeat twice, thrice, no problem. I don't have any mind. So please ask me again. Yes, Kavya, listen. So this is your enzyme. Okay, this is your enzyme. So this enzyme having one cup-shaped structure like this, whatever the may be, one open space is present. Okay, just think like this, open space is present. So it will move towards your substrate and it will start closing up your substrate and it will close like this. Okay, it will first it like this and it will start closing up when the substrate move inside of your enzyme, when substrate move inside of your enzyme. So it having the hydrolytic components in the curvy nature. So it starts cleaving off your heavy chain into small fragment, and it releases the product. If suppose I'm taking the enzyme or the substrate, this is your substrate. Substrate means the component which we wants to reduce the size. So this is a component, so we want to reduce the size of it. Okay, so this is a large molecule, that's substrate. Whatever we got, that is called product. So which one is doing what, which one is acting on it, that is called enzyme. So ಯಾರು ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅದು enzyme, ಯಾರ ಮೇಲೆ ಮಾಡ್ತಾ ಇದ್ದಾರೆ, that is substrate, ಏನ್ ಬಂತು last ಅಲ್ಲಿ, that is your product. So these three words are very important: enzyme, substrate, and product. What do you mean by enzyme? Enzyme is in protein that having the nature of catalysis of a large molecule into, it can convert a large molecule or bulk molecule into small fragments. What do you mean by catalysis? Catalysis means the conversion of heavy molecule into a small molecule by the hydrolytic activity. So what do you mean by substrate binding site? It's a site present on your enzyme. It is a site present on your enzyme where the substrate can sit. Where the substrate can sit on it. Okay, fine. Are you getting my point? Have you cleared, Kavya? Okay. Okay, fine. Because you should know this basic. So then I'll continue forward. If you didn't understand this, so it will somewhat difficult to understand the further. That's why I'm asking. Does everyone can understand? Yes, Meghana. So only carbohydrates will act on the substrate. That is my question. Very good. So now, can you tell me? Okay, now can you tell me? I just gave the example of carbohydrates because you know carbohydrates components like if I give an example for polysaccharides, disaccharides, you can know. So that's why I gave an example for carbohydrates. Does now my question is, does this enzyme, what we call it as proteinic enzyme because it's composition of protein, does only digest carbohydrates? Does only digest carbohydrates? It doesn't digest any proteinic or lipid or any other components? Does it only meant for carbohydrates? Whatever the enzymes. Because why I'm asking this? Because your enzyme is in protein. Does it having the capacity of break of your protein itself? Can anyone say? Gokul, tell me clearly. Like, does actually it's a very interesting thing. You should focus on it. Like, when I am saying the images should go on your mind, then only you'll get a clear picture. Like you're thinking that it's a going movie. Then it will be a fantastic thing. So just say me now. Does it only digest carbohydrates or not? Google saying no. Okay. Others? Others? Fast. So I'm giving you 1 minute time. Until that, I'll take attendance. So please inform me. Fast. Nikhil saying no. So you both are saying like it's a possibilities of digesting other than carbohydrates also. Is it right? Protein, yes, Google saying something. Just a second. Yes. Gokul saying like protein can consume any substance, not only carbohydrates. You mean to say, yeah, ಇದು maybe no, might be no. Meghana, yes, Meghana, it can be anything. Almost you're nearby for the answer, Gokul. Like it can digest whatever the component. Srujan, it will digest carbohydrates and fats and protein. So you mean to say, Srujan, it can digest all compounds. Fine. Nikhil, okay. Yeah, ma'am. The substance can be fat or carbohydrates. Okay, no problem. Meghana, me, ma'am. Don't know. So all protein, long chain can be converted into small units. Yes, in form of starch. Yes, I'll conclude it. So now, enzyme may be the component of protein, or enzyme is from the proteinic structure, but it having the capacity of digesting carbohydrates, protein, lipid, whatever the components you have. So what I'm saying now is enzymes are in protein which having the capacity of digesting all the components that you are taking from the food. Okay, does it fine? So enzymes having the capacity of digesting carbohydrates, protein, lipid, fats, whatever. Fine. Next thing, that is the first question. I think Meghana, you got your answer. Okay, now this is the first part, then leave it. Next. So as I informed you, this is your enzymatic part and this is your substrate. So it will digest, no problem. But this is enzyme is an protein part, right? So the proteinic part of your enzyme is called it as, the proteinic part of your enzyme is called it as apoenzyme. What I'm saying now, these words, so you have still more 3 words. These are very important for 1 mark question. Apoenzyme. So what I mean by apoenzyme? The proteinic part of an enzyme. The proteinic part of an enzyme is called apoenzyme. You can say now, ma'am, now only you are saying the enzymes is made up of protein, but now you are saying the protein part. So you mean to say all enzyme portions, or we can call it as apoenzyme? Somewhat like that only, but not sure. How means this is a composition of protein. Yes, of course you are right. Enzyme is a composition of protein, right? But in middle some metallic component can be exist, some metallic component can be exist, that is called metalloenzyme. So are you getting my point? In between that, in between the amino acid sequences, some metal can be exist. That is called it as metalloenzymes. So you know 2 words. That is, one is the proteinic part of your enzyme is called apoenzyme, and the metallic part of your enzyme is called metalloenzyme. Okay, metalloenzyme. Yes, Meghana. No, now it is a combination of substrate as well as protein. Yes, Meghana, you're right. See, Geeta, can you please rename yourself? See now, the enzyme can be occur in 2 states. Whether it can be in the free state, like enzyme doesn't bind to substrate, that can be occur in that state also, and it can combine with substrate and it can form a complex form. So see, I'm saying this is your plain enzyme. Okay, it can be exist like this also or like this also. This is called complex form. This is simple format. Okay, Meghana, like whenever you're taking food, the enzyme can bound to the substrate. Whenever you're not taking food, the enzyme can, as such, it can exist, no problem. Actually, but I get scared that you will get confused or not. But I'll try to convince in a simple way. Please re-log in whenever the class ends, because only 10 minutes we have. Please re-log in. So see, almost enzymes are in the free state. This is called inactive state. Okay, this is called inactive state. So what happen when this inactive state means without binding to the substrate? Okay, without binding to the substrate, it's in a sleeping mode. You can think like that. It is in a little louder. Okay, Mohammed. So this thing is there, no? Your enzyme. This enzyme is basically in the inactive form. Okay, this is basically in the inactive form. So this inactive form is called it as inactive enzyme. Inactive enzyme. So it doesn't binding to a substrate, it doesn't cleaving, it doesn't hydrolyzing. So it's simply sleeping over there. That is called inactive. So what happen whenever food entering into your body, whenever the food entering into your body, the enzyme need to get activate, right? The enzyme need to get activated. So what happen? That enzyme need activator. That enzyme need activator. Suppose you are sleeping. Okay, you are sleeping. So you need to get up, but the person is making you to get up is maybe your mom or maybe an alarm. Okay, so we need some what to say, precursor. We need some motivation. We need some what to say, I didn't get a proper word for that. Some initiator. Yes, some initiator. So we need some initiator to make us active. So as same like that for enzyme also, this is an inactive condition. The inactive condition should be active whenever you get a food. So that will be acting by an initiator. Initiator, or you can say precursor. Precursor, initiator or precursor. So where does it will bind? It will bind to an enzyme. That site is called as activator site. Are you getting my point? That is called as activator site. So whenever the enzyme is an inactive state, the enzyme should get active. That activity or the activation of your enzyme will done by the initiator or precursor, and it will go and bind to the active site. Okay, that will go and bind to the active site. When it's bind, the enzyme start getting it up. Okay, that enzyme start getting it up. So now we have a enzyme, that is proteinic part, that is called apoenzyme, and metallic part of an enzyme, that is called metalloenzyme, and the non-proteinic part is called as coenzyme. Non-protein part is called as coenzyme. This active site binding initiator or precursor or activator, you can say like this also, activator. So this activator is an non-protein. It should be a non-protein. So that part we are going to call it as coenzyme. Okay, are you getting my point? Coenzyme. I'll repeat. So enzyme is made up of protein. Okay, enzyme is made up of protein. All enzymes are protein, but all proteins are not an enzymes. The differences between enzyme and protein: enzyme having a substrate binding site. It can having the capacity of hydrolyzing your larger molecule into a smaller molecule. That is called it as enzyme. So enzyme is an proteinic part. The proteinic part of an enzyme called apoenzyme. The proteinic part of an enzyme is called apoenzyme, and non-proteinic part of an enzyme is called coenzyme. The non-proteinic part of an enzyme is called coenzyme. In that coenzyme part, activator can bind. It will convert the inactive state of an enzyme to the active state of an enzyme. So it will convert the inactive state to the active state, And the enzyme contain metallic groups, that is called metalloenzyme. So you need to remember three words: apoenzyme, metalloenzyme, coenzyme. Coenzymes means non-proteinic part. Proteinic part called as apoenzyme. Metallic part of an enzyme is called metalloenzyme. Fine? Is it fine? I go a bit faster? Okay, then. So next, these enzymes are a sequence of amino acid. Yes, of course, we know that because it's a protein, protein will be of amino acid sequence. Yes, of course, you're right. Sequence of amino acid is called as an enzyme. Yes, right. So the enzymes are specific. This word you should remember. The enzymes are specific. What does it mean? It means to say, suppose I need to digest carbohydrates. Okay, I need to digest carbohydrates. So for this carbohydrates, you have specific enzyme called amylase. So amylase enzyme is the name of an enzyme. Amylase is the name of an enzyme. This amylase enzyme is only meant for carbohydrates, not for any other components, like not for protein, not for lipid. It won't digest. Okay. So amylase is an enzyme that is only meant for, it's only there to digest your carbohydrates, not of any other compounds. That is called specificity of an enzyme. You should remember, you should underline this word. Specificity. We didn't use any of this word in any other concepts. ಈ specificity ಅನ್ನೋ ವರ್ಡ್ ನಾವು enzyme ಗೆ ಬಿಟ್ಟು ಬೇರೆ ಎಲ್ಲೂ ಯೂಸ್ ಮಾಡಲ್ಲ. We won't use this word as an specificity. Remember specificity? Each enzyme having its own particular product. Okay, its own particular product. Harshita, because of internet issue. Okay, I'll repeat, no problem. So these enzymes are seems to be very particular. These enzymes are very specific in their substrate, to their substrate. This is called specificity of an enzyme. This is called specificity of an enzyme. And we know that enzyme will act on a substrate and it start hydrolyzing. Enzyme or act on a substrate and it start hydrolyzing. That activity having an specific condition. Specific condition. What does it mean? It means to say under certainable condition only it will work. Okay, under certainable condition only it will work. It means to say, if you are maintaining the temperature, if you are maintaining the pressure, if you are giving a favorable condition, then only the enzymes start hydrolyzing it. So you just do one thing. Take one one wrist of your rice and put 1 spoon of saliva over there. Does it digest outside? After some time, can you able to see that starch or whatever the rice pearls you have, does it convert into a small piece of fragments? You just do it today. Take one wrist of rice, cooked rice. Okay, take one wrist of cooked rice and keep one spatula of saliva. Put one spatula of saliva. Leave it for 10 to 20 minutes, because anyway our maximum time of digestion is 20 minutes. So leave it for 10 to 20 minutes. After that, can you just observe the presence or the digestion of your carbohydrates over there? If it digests, enzyme can be act on any condition without any restrictions. If it not digest, it should maintain some certain temperature, pressure, and all favorable conditions. Okay, so by this we'll finish up our enzyme. So in our next class, in our next I'll relaunch now, right? So in that time I'll start taking up your antibodies. That antibodies you have a little bit, so only 5 minutes. I can finish it. Otherwise, can I do it for tomorrow? Can I do it for tomorrow or can I take it now? It's your choice. Please tell me fast. Anyway, the class has been ended. We don't have time.